You know that classic argument, right? The one where you walk into a room and say, "Wow, it's freezing in here," and your friend looks at you like you're crazy and says, "What are you talking about? It's perfectly warm." That simple disagreement, well, it actually gets to the heart of a huge idea in science, the difference between what we feel and what we can actually measure. So how do we bridge that gap? How do we get from a personal feeling to a scientific fact? Let's dive in.
So here's our game plan. We're going to start with a simple question of feeling. Then we'll get into something called the subjectivity problem. After that, we'll find a better tool for truth and really compare hard data versus just a sensation. And finally, we'll see how it all comes together in a really cool scientific partnership.
All right, let's kick things off with something we all do, all day, every day, using our own experience to figure out what's going on in the world around us. But just how reliable is that really?
Okay, picture this. You need to know how hot a bowl of water is. What's the first thing you're going to do? You stick your finger in it, right? It's automatic, it's fast, and you get an answer right away. Yep, that feels warm. Or, ooh, that's pretty cool. And it feels like a solid fact, doesn't it? But here's the catch. What happens when someone else tries the exact same thing? Are they going to feel the exact same temperature? This is where things start to get interesting.
And that little moment of doubt, that potential for disagreement, leads us straight into what's called the subjectivity problem. It's the big reason why, in science, just trusting our gut feeling isn't quite good enough.
So here it is, plain and simple. You've got one person saying the water feels warm, and another person, dipping their hand into the exact same water, says it feels cool. So, who's right? The tricky part is, from their own point of view, they both are. But science can't work with two different truths. It needs one single, verifiable answer. And this kind of disagreement is a major roadblock.
And that right there is the definition of subjectivity. It means our observations are being filtered through our own personal stuff. You know, maybe person B was just outside in the snow, so of course the water is going to feel way warmer to them. Their personal experiences are changing their observation.
And this leads us to a really fundamental principle in science. Any observation that relies only on our senses is, by its very nature, subjective. And because of that, it's pretty much always going to be less accurate.
Okay, so if our senses can be so easily fooled, what's the alternative? This brings us to part 3, finding a proper tool for truth, something that lets us move beyond our own personal perceptions.
Luckily for us, and for anyone who wants a real answer, there is definitely a much, much better way.
And the answer is measuring equipment. We're talking about tools like thermometers, rulers, and scales. A thermometer doesn't have an opinion. It doesn't care if it was just holding a cup of hot coffee. Its only job is to give us precise, objective data every single time.
So, let's really put these two head to head. Cold, hard data versus a simple sensation. This is where you really see the power that a precise number has over a vague feeling. First, let's talk accuracy. An accurate measurement isn't just a random guess. It's a number that gets us as close as humanly possible to the true, correct value of what we're measuring. Our senses, as we've seen, can be way off the mark. And then there's its crucial partner, reliability. This is all about consistency. It asks the question, if you measure the same thing again and again, are you going to get the same result? A good scientific instrument will give you that for sure. Our senses? Not so much. How that water feels to you could change completely 5 minutes from now.
I mean, just look at this comparison. It says it all, right? For accuracy, our senses are low and all over the place. Instruments are high and specific. And for reliability, our senses are subjective and inconsistent, while instruments are highly repeatable. It's a total knockout win for the tools.
So instead of arguing about warm or cool, a thermometer gives us this. Boom. 37.5 degrees Celsius. It's specific, it's accurate, and it's reliable. It's a piece of objective data that person A and person B can both look at and agree on, no matter what they personally feel. So, does all of this mean our senses are totally useless? Absolutely not. For our final section, we're going to see that this isn't about senses versus tools. It's about a scientific partnership, combining our natural human curiosity with our amazing, powerful instruments. I mean, think about it. Our senses are the spark. You feel the water and you think, I wonder what the actual temperature is.
That question, the one that kicks off the whole investigation, came from your senses. Our senses are fantastic at asking questions, we just need our tools to find the reliable answers. And that right there is the path to discovery. It starts with our senses. We notice something. That sparks a question. Then we bring in the instruments to measure and get that objective data. And only after we analyze that data can we draw a conclusion that we can actually trust.
So at the end of the day, it's not a competition. It really is a partnership. Our senses start the conversation, they get us curious, but it's our tools that provide the cold, hard facts we need to find the truth.
And that leaves us with a final thought to take with you. As you go about your day, relying on your own feelings and perceptions, it's worth asking yourself, what are some everyday beliefs that I hold, just based on a feeling, that might not actually stand up to objective measurement?